Okay, good afternoon, everybody. My name is Gavin Craik. I'm the Senior Technical Content Officer here at the ETSI Secretariat, and this is the first of a two-part scheduled ETSI webinar. This part 1, is the overview of the OSM Release 7, and part 2, which will be tomorrow, is on the running of cloud-native network services with OSM. So the first webinar today will give you an overview of open source MANO, the main highlights in Release 7, how to achieve full life cycle automation of real network services, and how to enable self-monitoring of OSM components on Kubernetes. We have 3 presenters today. Francisco-Javier Ramón Salguero, the Chairman of ETSI OSM, Gianpietro Lavado, the OSM VNF Onboarding Task Force Chairman, and finally Francisco Rodriguez from Minsait. All have been heavily involved in the activity, and hence they are very well qualified to give this webinar. Before I hand over to our speakers, I'd just like to remind you of some quick points about the webinar today. First of all, a recording of the webinar will be available on demand a few minutes after we've ended, in the same location as where you are right now. Feel free to ask questions at any time by clicking on the Ask a Question button. We'll handle questions at the end of the webinar, and if we don't answer your question, don't worry. We'll get back to you after the webinar by email. We've also attached slides in the PDF form on other useful information, and you can download them from the Attachments button. And you can share this webinar using the social media buttons above the viewer and rate it with the Rate This button. Now I shall hand you over to our presenters. And so first of all, to the OSM Chairman, Francisco.
Thank you, Gavin. Good afternoon, good morning, everyone. This is as this was described, this was is a series of webinars, two webinars where we want to describe in depth what OSM, the latest release of OSM, brings in terms of functionality and the kind of use cases that are enabled in this release. Since this is a complex topic, because we have many things that I would like to show, but obviously, I mean, it will require a large amount of hours to cover extensively all the topics about OSM. We've tried to focus on the most relevant for you, particularly the newest, that are new things that come with OSM Release 7, but also wanted to give you an overview on the advanced use of what of OSM and the things that it brings for you. Okay, so in this part, I would like to answer one of the main questions is, why do I need OSM, right? What OSM provides? Because obviously you might have thought that you need, you are in an NFV environment and you may need the support of an orchestrator, but the point is, well, what should do an orchestrator for me, okay? And so we'll describe what OSM provides. So OSM, I mean, in the most simplified view, and from a user perspective of the platform, it provides the ability to create networks on demand, networks as a service. And that type of networks can be in 2 forms. I mean, can be a network service, that's a well-known concept from ETSI NFV, but also being able to create those networks as a service as slices, okay, as network slices. And one of the key characteristics is that you request by this normal interface the creation of a new network of a given type, and I will take charge of requesting other platforms underneath to do whichever that are the micro activities that are required to build from scratch that network and also operate it successfully later. Okay, so this is a simplified view of the complexity of what happens here, but in the end, what you are creating is a network from scratch based on something that you are describing. And actually, this is has two aspects. What happens outbound is that you can create a network on demand, could be together in a single location in a specific virtual domain, but also more likely you want to expand it across several locations, across several technologies of virtualization, several transport technologies, several type of components, not all of them virtual, and you need to take into account. Or even better, you want that OSM takes them into account for you. Okay, so that is the scope of what OSM does for you. Okay, how does it do it? I mean, I'm feeding OSM with models, so I tell OSM what I want it to do for me. So the models are key here, because I'm from a user perspective, everything is based in models, a COM package, right? In order to decompose that description, there are different levels of description. I mean, I could have the descriptions of the applications, the network function packages. I would have network service packages. I mean, the composition of several network functions to build a complex network service. But also, I can even work on a third level on top of that is working at network slice level. Okay, and each of them have their models, and they refer to the others to build a complex description. Actually, what is happening is that I instruct the system based on those models, and the model and the system does on our behalf whatever interactions that need to be driven to the beams or the WIMs or the physical network functions. In this case, we are used it in the case of the beam, and OSM takes care on the particularities of the different technologies of beam via a collection of connectors for beams or SDN. Okay, so we let the beam to do its thing, right? And whenever that everything is created, we use the other part of the models to drive those operations to configure them, to run specific actions of day 1 or day 2 in the components. Okay, and we do that trick having an execution environment in the BCA component of OSM, where we can embed the operational software for those VNFs. Okay, so the view again, and I want to retake the view from a user perspective. What you have after all these things have happened underneath is that you have a handler for your network service, so your network service instance or your network slice instance, and you can and that is available as an object, as a first class object that you can use. Okay, so you can drive the operations later. It's key in all this, as I said, the information model in OSM. You know, it should embed all the complexity that I've described, and in particular, what OSM guarantees you is that regardless which application you have, no matter what application you have, no matter what environment you have, either for testing or for final application, it will guarantee that it will behave the same. So the package is preserved across all the supply chain. Okay, so this is very powerful because it's one package for multiple infrastructures, and also will allows to embed the complexity. So many of these steps that you need to describe an application in general, right? So if you analyze a process of using an application for real, in the end, many of the steps might require some type of the reverse engineering. This is precisely what you avoid when you receive a BNF package of OSM. All these steps are already embedded, so essentially you don't need to perform those activities over and over because they come with the package. So your initial testing and finally your use of the application is totally replicable without that complexity. Okay. So from a different perspective, if you are a BNF developer and you want to reach quickly a huge number of customers, regardless the type of infrastructure that they have, regardless the use cases that they are running, because your application might fit to different use cases, actually. So initially you have a BNF better software, but if you provide it together with a BNF package, essentially you are reaching all of your customers with that same package without recodification. You can pass a certification, but also even each of those customers can be using that same package in different network services, totally different network services, and even further, you can instantiate them in different contexts. So you might have different contexts for operation and all. So that is the power that gives you the package. Okay. Okay. So so obviously you need to avoid hard-coded values, etc. But that is. So this is what is the theory, but what is the practice, right? But the practice what we have where we are in OSM is that we are in a very large and diverse community with 137 members today, if I'm not missing any last member. Okay, so it's very diverse community. As you can imagine, we need a lot of expertise from different type of players. Okay. And also we have what is called the OSM ecosystem, which is a listing of companies who are offering products related or based on OSM, right? It's like the OSM yellow pages if you want. And as you see in the ecosystem of OSM, this is just the tip of the iceberg of what exists behind OSM is really huge, right? So I won't enter into much detail because time is limited, but I mean, this is definitely one of the aspects that we are really proud of. We are building a solid community with commercial offers behind it. Okay. About Release 7, I mean, what is the relevance of Release 7 in all this? Because I mean, mostly everything that I've described now is already, I mean, is already there for a while. But OSM Release 7 improves substantially this framework in terms of flexibility. First of all, because it incorporates a new type of applications that can be also used in OSM in the same fashion that I mentioned before. I mean, Kubernetes and cloud native applications can be used from Release 7. And actually, we'll spend tomorrow. We'll spend the whole session on discussing, or almost all the whole session, besides one very specific topic, discussing about Kubernetes. So I won't talk much about it today, but the thing is that this is one of the top enhancements of OSM in this release. Also, we are improving the planning and optimization capabilities of OSM with the capability of optimizing the placement, deciding what is the target, if you request so. Okay. Also, we are extending the capabilities to supporting different types of infrastructures. We are adding to the large list of infrastructure that we supported. We also adding Azure as one of the types of public clouds that we are supporting, and also we are supporting a large number of SDN frameworks that we did not support in the past. So we have almost duplicated the type of SDNs that we are supporting. We have improved a lot the lifecycle and the feedback that we are providing to the user. From user perspective, the experience is totally different, okay, for the good. We are improving the fault management and the performance management and all the dashboards that we are providing, so that information in graphical terms is much better. Actually, you will see some demonstration today about this topic. The BNF onboarding has been improved. I mean, the experience in terms of the tooling that is companion to OSM is we believe that is a really good step in terms to ease the onboarding process for developers. And well, we have migrated the code bases to Python 3. There were some parts of the code base that were still Python 2, so we have migrated everything that we needed. Okay. About cloud native applications, I won't spend much time today on this, but essentially what we are saying is that we are able now to combine container-based applications with VM-based applications with physical network functions applications, all together driven by OSM, okay? And with the same northbound interface. In that normal interfaces, we are incorporating all the lifecycle operations that you are used to in a Kubernetes environment, so we are not breaking the model. In this step, we've made it in a manner that is totally compatible with the pre-existing applications for Kubernetes. So you don't need to create an onboarding process for them. They can be used in a matter of minutes actually. And we are really proud because it's extending the ecosystem of applications running in OSM really well. Okay. Yeah, and then the overview of the webinar is the following. I mean, today, besides this presentation, we'll be running. We'll be running some demonstrations, some about running real network services with OSM, and other on monitoring the OSM platform. Tomorrow will be the day for cloud native and for automatic placement. So, well, that would be a really long sufficient time to understand how is the experience with that. Okay. Of course, this is short. I mean, the time is short. I mean, 2 webinars are not enough to master OSM and to understand all the capabilities that OSM has, how to do it, etc., etc. We are totally aware of that. We are only trying to, well, tell you the newest and brightest. But if you want to learn more, I mean, we are kindly invite you to the next OSM Hackfest. In the next one is in Madrid in early March. So you are kindly invited to register. Okay. Okay, and that's it for my slot. I will pass the control to Gianpietro Lavado, the chair of the VNF Onboarding Task Force of OSM.
Thanks, Javier. Can you hear me well?
Yep.
Yep. Okay, great. So in this part of the session, we will see an overview of Release 7. You will see the most mature features and a demonstration of the main things we can achieve with OSM today, while we prepare for the most advanced sessions that are upcoming today and tomorrow regarding the cloud native additions. So I'll put things like this to summarize what OSM is bringing to the industry. We think that this is has become the management and orchestration solution of choice for operators that want to focus on horizontal operator-controlled NFV environments and with a special focus on automating operations. We talk a lot about automating day 0, day 1, day 2 operations, and we are convinced that OSM is the best solution that can achieve that over network services and network slices. So let's go through the main features or the main highlights of OSM today. First of all, I would say that installation is the way OSM is installed is one of its advantages, because it just consists in running a script over a given infrastructure with a minimal requirements, and that's it. When you launch the script, the Docker images are downloaded, and the OSM services are launched either over a Docker Swarm environment or a Kubernetes environment with a single unattended script, and then you've got OSM within minutes. So OSM itself is a cloud-native application that runs completely over Docker containers, and that I think that's one of the main reasons that we have a very big or large and active community, because it's easy to get OSM even on your personal computer. A second feature that I would highlight is the system monitoring. Since Release 7, the system is completely monitored through, well, a Prometheus system that finally exports dashboard to Grafana, and the whole system can be monitored in the Docker Swarm installation, as you can see in the GIF there. And we have some more advanced features when you install OSM in Kubernetes, which you will see right after this session. So you can see, for example, if the system is okay, and if the Docker container is failing, the CPU consumption and all the details about the environment where OSM is running. Then role-based access control is a feature that we launched the release in release 6, but today in release 7 is a strong feature that I think is important for production environments and is already connected to the dashboard. So we can just, with creating a project and then creating a user and then associating that project with a user and a role, you got your own environment, your own private environment for a particular department in your organization. So I think this is important. This is huge for having a single OSM installation serving different departments. So you don't have to have multiple deployments if you want independent OSM environments. Then, well, okay, you've got your OSM system, but now for running network services and network slices, you need a VIM, right? A place where you send your instructions to instantiate virtual machines and containers. And VIM integration is also very simple to do. And well, we support today different kinds of VIMs, support OpenStack, VMware, even Amazon Web Services, Azure, and other clouds. That with just giving the API credentials, you already have a connection to the VIM, and OSM can orchestrate the resources over there. So then OSM uses plugins to translate all the requirements of your descriptors to what actually will be deployed over the infrastructure. And OSM takes care of that. So you don't have to deal directly with the VIM anymore. You don't have to go to OpenStack necessarily. You just describe your VNFs in a human language in OSM, and then you got what you need. OSM takes care of everything. So you just fill the basic credentials, and then you optionally fill some advanced settings, and there you go. After having a VIM, you need to onboard your VNFs, of course. So for that, OSM brings a lot of tools and documentation to successfully onboard any VNF, even if it's a complex one. So we have tools for generating the packages automatically. Then we have tools embedded, for example, in Visual Studio for checking if the format, if the model is being followed before actually building the package. And then when you are done with your descriptors and the contents of your package, you just compress it and then drag and drop it into the dashboard, and there you have the VNF package. So it's very easy a process very easy to follow, and we actually have a very comprehensive VNF onboarding guide that is a product from a specific task force that we have in OSM that dedicates to that. So that we are trying to simplify and document very well the VNF onboarding process. Then we have the hybrid network services support. So here, what we want to do is take control and orchestrate not only what's happening in the virtual world, also when you launch a VNF in the real world, you have to touch some components in the data center, right? So you have to configure a static route, for example, or a VLAN or a VRF in the router, in the gateway. You have to configure rules in the firewall, maybe. You have to set some VLANs in the switches, and many things that occur over what we call PNFs, physical networking functions. So switches, routers, firewalls, data center gateways, load balancers. Those in OSM can be also part of your network service. So we model them we first make them available to our system by adding them through a simple form, and then multiple DNFs can use it by just referring to it through the descriptor. So it's at the end, the PDU or a PNF is treated like a virtual or described like it was a virtual component, but it gives you the advantage that you can run day 1 and day 2 operations over it. So when the network service is launched, you get the configurations of your DNS, and you get the configurations that you need on your physical environment. So you are ready to just serve your customers, or serve your internal or external customers from your networking functions. Just launch and forget. Then you have the instantiation itself. After modeling, it comes, after having the packages in the platform, you instantiate. This is a very simple process as well, but what I want to highlight here is that when you launch a network service in OSM, you have the possibility to pass instantiation parameters so that you can keep using a unique DNS package for any deployment that you have. And according to the particular infrastructure, you will pass some additional parameters at instantiation time so that you always use the same package and just tweak some other things particular for the given infrastructure where you are deploying your services. So, well, at the end, it's just a matter of filling out a form or using the OSM client and launching the DNS, and it will start launching the services. And at the end, it will, after the VMs are launched or the Docker containers are launched, the system will run operations over it so that the DNS is ready to provide the services. So, talking about this, what happens after launching, OSM is not an orchestrator that is just launching virtual machines or Docker containers and that's it. For that, we have other components at the Vim level. We are at a higher level. We understand about network functions. So what we provide is configuration of those functions so that the professional services that are typically tied to any network service deployment nowadays are not needed anymore, because everything or most of the operations, most of the services that are required for installing, configuring a DNS are automated within the package. That's what we are trying to achieve, and that's what we are actually achieving nowadays with day 0, day 1, day 2 automation mechanisms. In particular, we use a cloud init that's very standard for day 0, and our DNS configuration and abstraction model for day 1 and day 2, what we implement through a mechanism called proxy charms or native charms, which are a set of scripts that will run on your DNS and are highly customizable. Of course, we need to know what's going on with our network services. So in the past, in OSM, we have supported monitoring metrics of the infrastructure of the DNS and configuring those metrics to be exposed in a Grafana dashboard. That is being automated today in Release 7, so that whenever you create a new network service, you go to OSM Grafana and you've got already the parameters that you need to monitor there. So you don't need to configure things further. So look what we are trying to achieve here. We are trying to simplify operations. That's what we are doing with DNS. You launch your DNS, and the DNS is ready to provide services, and it's also automatically being monitored. Finally, what I would like to, of course, there are a lot of features that, like Francisco-Javier was saying, but we want to highlight the main ones so that you get an idea of what OSM is providing to the industry. This last feature I want to highlight is the auto-scaling feature, which provides automatic scaling in and scale out of the BDUs, your DNS components, when some metric has been, a metric threshold has been crossed. So that's completely customizable as well. When a metric crosses a threshold, the system detects that and the BDU just scales out or in. So that's all the features that we think that are the main ones to highlight. Of course, there is network slicing. There are also features for launching cloud-native applications, which we will see in more detail in the next sessions. But now we would like to show you a live open source MANO demo. We'll launch a real-world DNS. In this case, is a packet core based on Facebook's Magma project. This particular network service is composed of 3 DNFs. We have an orchestrator, and we have the access gateway, and we have federation gateway in some cases. In this particular demonstration, we already have deployed an orchestrator, and we will deploy many access gateways, simulating that an operator needs to deploy virtual packet cores in many places at a time. So this access gateway, in the concept of this DNS, Facebook Magma, it's running a S gateway, a P gateway, and the NNE, everything embedded in a single machine. Okay, so we will be deploying that. At the end, what we would like to show is that in this particular demo, you can get distributed LTE packet cores in minutes, already monitored, automatically initialized, configured, and registered into the orchestrator, and using, of course, the automation features of OSM. So let's go to that. You will see now my screen. And you will see that we have an open source MANO. You have open source MANO already installed here. We have some network service packages, some DNS packages, and we have the Beam ready. This is OpenStack with a few virtual machines in there. We have a Grafana that comes with a open source MANO as well. So you can see here, for example, that when you install open source MANO, you get the OSM system metrics automatically. In both ways of installing open source MANO, there is Docker Swarm or Kubernetes. You got all these already without you needing to enable anything. And as I was saying, we already have deployed one part of this network service, which is the orchestrator, and this is the orchestrator of Magma, which is the packet core I'm talking about. So it doesn't have any gateways configured yet. So suppose that we have the orchestration of the DNS ready. This would be like the EMS of the network service, and we need to deploy the gateway now, which would be the packet core. Okay, so here we have the command line of OSM. You can see that we don't have any network service. And what I use for launching network services is that it's command line scripts. So I will show you the script that we will be using today. You can see here that we will launch, just a minute. Okay, this is the script that I will use. It will use the nscreate command of OSM, launching the NSD, which is called Magma AGW, over the given Beam, which is called White Cloud Admin, and using a configuration file, which is called AGW1. And we will run that 4 times. That is, we are deploying 4 access gateways with different parameters each. This is the instantiation parameters I'm talking about. And we have another optimizations for the environment for running the primitives or the day one operations faster. And that's it. That's the only thing that my script is doing. Let me show you also the parameters that we are passing. So you can see that it's something simple. We are passing the name of a provider network, which can vary from beam to beam, from site to site. So we are passing that. And we are passing the name of the gateways. In this case, it's gateway 1, and the IP address of the orchestrator, because the gateway will register itself. We don't have to configure it manually. Okay, and so let's launch this. I will run the script. So it is instantiating the gateway 1, gateway 2, and while that is happening, we will see that the network service instances are appearing here. So let's go to network service instances, and we will see 4 access gateways being deployed with different instantiation parameters each, and they will also automatically register to the orchestrator. We will see that they are appearing also here in the OpenStack environment. What I would like to show you now is how these DNFs are described. So let's look at the descriptor of that access gateway DNF. It's just a YAML file which describes all the DNF. Very easy to understand. We have the monitoring params the metrics we want to get from each access gateway. So we have CPU, memory, packets, sent and received. We have the main features of or characteristics of the VDU. So for example, we are asking for some dedicated resources here, pin CPUs, memory switch pages, which are typically used for VNFs for getting high performance and getting high throughput. We are specifying the image. We are specifying the number of interfaces. The monitoring params we are getting, we are mapping to the VDU. The flavor, how much memory, storage, and CPU we want. And also we have the DNS configuration. So this is what actually implements day one operations and day two operations. What we're doing here is as soon as the VM is deployed, it will reset its identity. It will add itself as a gateway in the orchestrator. And these are all parameters that we are passing. It will add this is a script that will add the orchestrator IP to the net name resolution of the host. And finally, it will restart the Magma services. So after all these operations happen, you have an access gateway up and running. You don't have to go and configure it manually. It's ready. It's just ready to provide services. And the charm we're using for that is called Magma Gateway. So now let's have a closer look at those operations so that you can see how customizable are that kind of a script. Okay, so this is how a charm looks like. You have operations. So we have a reset ID operation, which just gives an identity to the DNF. In this particular case, we have a script for adding itself to the orchestrator. We have the add hosts script. We have the restart Magma script. So this is just Python. So you can implement whatever you want here. You can say configure my DNF, put a huge script here that will do everything for you, and you don't have to repeat it over and over when you deploy your VNF. So that's the magic of our VCA component. You can express what you want to do in your VNF here, and you can use for REST APIs, for communicating with the VNF. You can use SSH. You can use Ansible You can use Sol2, which is standard of ETSI. You can implement whatever you want in these functions. Okay, so let's go back to the instantiation. Okay, we see the virtual machines are ready. Let's take a closer look at those virtual machines. We said that we would provide some EPA, right? Some dedicated resources. So the flavor we're using here, let's see if it actually was orchestrated right with dedicated resources. So this is the flavor, and we can see it has some metadata. This is OpenStack, so we are exploring how things were orchestrated by OSM, and you can see that OSM asked for dedicated CPUs and asked for large memory pages for this VNF to perform faster. Okay, so this was all orchestrated by OSM. You don't have to communicate directly with your beam in any case. We also have in Grafana some dashboards appeared automatically. You can see here 4 dashboards, one for each network service. So let's click on one of them, and you can see that it's already starting to monitor memory in this case. As well, you can see other dashboards as well, and you will start seeing the CPU, memory, and network traffic metrics being collected over time. This is depending, of course, of the granularity of collection. Okay, and finally, let's see the orchestrator. So the orchestrator now sees 4 access gateways configured and in green state that is ready to provide services. So what happened here was open source MANO took the package, which included all the definitions, so they 0, 1, and 2 operations, as well as the description of the VMs, and deployed everything, deployed the access gateways, and also configured the access gateways so that they are all ready to provide services. Let's see here the status in OSM. Okay, you can see there that the VNFs are running and the VNFs are also configured. Okay, so let's go back here. There's another dashboard that I would like you to see, which is the project dashboard. It's also automatically created. You can see that this is the project admin in OSM, which is the one we're looking at. And you will see that it has a beam. The beam is up. It has 4 network services. Each network service has 1 BDU, and all the network services are up. If something fails, for example, a VM is down, a compute node is down, everything will, that status will reflect here as the network service being down. So that's an important dashboard, simple but very important, just to get an overview of the services that are running. So we also talked about day 2 operations, and this just to finish the demonstration, we will go into one of the gateways and see how a day 2 operation works. A day 2 operation is an operation that you run on demand whenever you want as an operator to run it. So let's go into access gateway 1. This is the IP address. Sorry about this. Okay, so let's go into access gateway 1. Okay, so we have access to the VNF to the management network, and we will monitor its logs. Okay, so this is the logs showing that it successfully registered to the orchestrator. Perfect. And now we will run a primitive, what we call a day 2 action from open source MANO. We implemented many primitives like adding gateway, deleting gateway, restarting services. We'll just try that restarting service operation. So let's run the primitive here, execute actions. Let's make sure we are in the right VNF, access gateway 1. The primitive is called restart magma over the DNF1, and it doesn't have any parameter, so I will just run it. And soon after that happens, we will see that the services are being restarted in the VNF. So you can see that OSM has control over the VNFs during deployment through day 0 and day 1 operations, and has control of the VNFs after deployment, and you can implement whatever actions you want and operate your VNFs automatically through OSM and on demand. Okay, so that concludes my presentation demo. We have seen some main features of OSM. With the focus of this presentation was to show you that this platform is heading to, or is already there, ready for production environments. It focuses on real-world DNFs and real-world needs, and you can see that having the complete orchestration, the control over network service is very easy, and you can go from modeling through instantiation and beyond to operation of your DNF. Thank you. The following session consists on monitoring open source MANO in Kubernetes, and I will pass the presentation to Francisco Rodriguez.
Okay, thank you, Gianpietro. Indeed, I'm going to talk in the next few minutes about the facilities that have been added in the release 7 of OSM for monitoring the OSM infrastructure, the OSM components, the OSM, the hosts in which OSM is running when it is deployed in a Kubernetes cluster. So jumping directly to the point, probably what you want to know first is how to enable this feature, and this is as easy as launching the installer that Gianpietro demonstrated in the presentation before, using the switch for selecting the Kubernetes deployment, which is this -C cage switch, and then using the // cage monitor option, which is optional. I mean, you could deploy OSM in Kubernetes without deploying this additional monitoring infrastructure. Probably it's a good idea to do it in all cases because advantages are clear and the resource consumption is pretty low. Then, in order to access the dashboards that are enabled, is just a matter of pointing to the host in which you are doing the deployment using port 3000, and you will get access to a set of dashboard that I will describe in the following slides. Here you have a picture of the main one, the OSM summary dashboard, in which you can see each one of the OSM components and which state it is in. You can see they are all in green now, and then you have additional information on the number of pods that are running in the Kubernetes, the number of hosts, that's it, the virtual machines or the bare metal machines that are used for the deployment, and then the resource consumption of each one of the containers of OSM. We will go into a little more detail later, but first a few things to highlight. Again, this is available in the Kubernetes deployment of OSM. There is a similar feature for the classic deployment in which Docker Swarm is used, maybe not that complete, but what I'm going to describe in the following slide is referring to the Kubernetes deployment. Another thing, just in case there might be some confusion there, is that what we are monitoring, and this is for monitoring the OSM components themselves, not the VNFs or the network services. For that purpose, there is another component in OSM. There's another Prometheus instance, and this is the dashboards that Gianpietro was presenting in the previous presentation. This is a different component and different set of dashboards. And here, just a note on the implementation. This is based on Prometheus operator using the Helm chart that is available publicly with a little twist here and there, and some exporters that are also community-based are available in the corresponding upstream projects. Okay, here is a reminder of the Kubernetes, the OSM deployment in Kubernetes that you can deploy using the standard installer in the upstream. What this script does is to create a namespace, which is not very surprisingly called OSM, and then deploy there a set of components. In fact, it is 12 pods. Distributed in the following way. There are 5 stateful sets that are used for the modules that require some persistence, basically the databases and Zookeeper. There are then 7 deployments with only 1 replica each for the modules that are stateless. In this installation, in this community installation, there is no high availability and only 1 replica is deployed for each component. If you need a full carrier grade solution, you will have to go for one of the commercial available distributions. And also there's a caveat there, which is the VCA component is not inside the Kubernetes, is deployed in the same host as an LXD container, but this is separate. So the monitoring is not done on this component. On the dashboards that I'm going to show, you will see the rest of the components, but not yet the VCA. A detail about the implementation of all the components for this monitoring infrastructure are deployed in a different namespace in order to isolate it for the OSM namespace. If you list the pods there, at first glance you will see there are a number of pods, maybe too many, but this is how Prometheus operator works. And as I said, the resource consumption is not too high. I mean, you can run this in your laptop as the rest of OSM without any issues. You will see there in that monitoring namespace the Prometheus operator components, and then a few exporters that are in charge of gathering the information from the different sources and converting the format to what Prometheus is expecting. We are getting information from the host itself or the virtual machine in which this is running, from some software components of OSM, mainly the databases, and also the information about the containers, the resource consumption of each one of them, and the own Kubernetes cluster is taken directly from Kubernetes that exports that natively without any need for exporter. Then if you identify yourself with the default password in Grafana, you will access this initial screen in which the dashboards are organized in 2 different folders. One of them is called Kubernetes, and there you will find all the information that is, all the dashboards that are in the community Helm chart that we have used for implementing this. We didn't want to remove anything, but you will find there a lot of information that, again, this is what is in the upstream project for Prometheus operator, for those that really want to go into the very gory details. But for those of us that are more interested in the more summarized things, there is this OSM folder in which there are a few dashboards with a little less information, but more relevant, so that you can go quickly to the interesting things. First is the summary dashboard. There you will find a very high-level summary on the number of hosts that are available. If you are using the community installation and you have not done any tweaking, you will have everything installed in one host. So you will see there are one, and if that host is unavailable for any reason, probably you won't be even able to see this this dashboard. Then there is information about the number of pods that are on. In case you have any failed pod, you will see this in a different color. In a standard installation, you will see there, I believe it is kind of 32 pods, because it is taking into account not only the OSM pods, but also the own Kubernetes pods and the pods that are used for this monitoring infrastructure. So this adds up to this number, which is higher than the 12 pods that make up OSM. The stages of those pods, as I said before, are in this section in the middle, and a little on top of that, you will see the resource usage for the Kubernetes resources in terms of memory, CPU, and so on. And this is the resources that have been requested in the descriptors to be reserved in Kubernetes. And then finally, you will see in a very summarized view the memory and CPU usage of each one of the OSM components. In this case, we are showing here only the OSM components and not all the support containers. Okay, then there is a dashboard devoted to the status of the host itself. There you have the information about the CPU, load, memory, disk usage, both in terms of how much of the total amount is used, and I/O operations being performed, a number of reads and writes per second, and the network activity. Just to highlight a small caveat here, also there's one arrow there showing the swap usage. That probably will always show non-applicable, because the Kubernetes deployment requires that swap is disabled. So this is why you see the green, yellow, and red there. But this is because this stat is not applicable. And finally, there are three. Oh, sorry for the glitch. There are three dashboards devoted to three specific key modules, which are Kafka, MongoDB, and MySQL. And there you can find the usual information about statistics on the number of operations being performed, reads and writes in the network, disk usage, and so on. Okay, the very last one with the gory details on how this is implemented and how Prometheus operator work, and this is the pods that you will see if you inspect into the monitoring namespace. So the key component is again another instance of Prometheus database, a different one than the one that is used for monitoring the VNFs themselves. And this Prometheus instance is getting information from the exporters that are adapting the format of the information as required by Prometheus. The interesting thing there is that the configuration of this Prometheus is created, let's say, on the fly, by the Prometheus operator component. Operators in Kubernetes are controllers that implement features similar to what a human operator would do. In this case, configuring the Prometheus to adapt it to our needs, according to the specification in the service monitor custom resource that is also in the monitoring namespace, as you can see, and you can see there. Those service monitor specify which targets should Prometheus get the metrics from. right? In just as a final note, if you want to customize the dashboards yourself, this is something that you can somehow easily do. They are stored in Kubernetes config maps. You can spot them easily in the OSM namespace, and basically they host the JSON file in which the dashboard is defined. It's just a matter of adding an additional config map with the JSON file, and then you will have your own dashboard as required. Okay, so that was all on my side. Just to mention, if you have any question, ideas, whatever about this component, please use the OSM Tech mailing list. And maybe finally, again, just remember the Hackfest that is going to take place in Madrid. There you probably will be able to learn about this and many other OSM features. I think it's totally free, so no excuse to come. And if you're planning to do it, I think it's a good idea to register as soon as possible, because well, the host typically receive a lot of registration in the very last days, and this becomes a little of a nightmare. So please do it as soon as possible.
Yeah, okay, actually, the name of seats is limited, so I mean, the sooner the better to grant a place.
Okay, thank you. Okay, now is the time to ask questions. If you'd like to ask a question, please click on the Ask a Question button and type it in, and I will then refer it to our presenters. And remember, if we don't get time to answer the questions or are unable to today, we will reply to them by email. So I see we already have a few questions, or perhaps comments from the audience. One is about when will release 7.1 be released? Can anyone tell me that?
I think any of us. All right. I mean, actually, it's in the the release that we are meaning is 7.01, which is in the oven right now, and hopefully, I mean, in 1 or 2 days when we complete the test plan that we are passing. I mean, each of the release candidates needs to pass an extensive test plan. If everything goes well, it will be released during this very week.
Okay. The next one is about, does Release 7 support high available deployment of the OSM, meaning 2+ deployments of OSM on different nodes, yet operating in coordination that is as part of the same cluster? If yes, they would ask if they could have a link provided for details about how to do it. I wonder if anyone can answer that question.
I'm not sure if the question refers to different geographically redundant sites, or having the OSM components in a site in a redundant fashion. What I would suggest there is to look at one of the commercially available OSM distributions, which are highly available and are able to provide this kind of features.
Okay. There's a further question about, will OSM release 7?
Yeah, another one comment about that. I mean, is that the things that, I mean, the code base of OSM can be used in that fashion. The thing is that in the community installer of OSM is fairly simple. I mean, it's much simpler on the deployment of the components that every single combination you could do in advanced setups with OSM components, and obviously the installers of the distros are way more sophisticated, and they cover a lot of setups, including different combinations of HA setups. Okay, so from the perspective of the code base is ready for this. You need to do a little bit of manual configuration after using the installer, but as Francisco has commented, the simplest is using one of the commercial distros that are also available for download, and they have the installer, and it's one of the options that they provide by default. Okay.
Okay. There is a question about whether OSM release 7 circumvents the issues of frequently running out of disk space.
We would need more details about that issue, because we had some disk issue identified in the past due to the Elasticsearch component, but that was resolved with a rotator, a component named Curator, that is included also with the stack. And as far as I know, there's no other log which is not rotating or something that would cause that kind of issue. So if you can provide more details to the Slack channel or to the mailer, we can help further.
Okay. Question about asking whether we can provide details on the Prometheus module for OpenStack, the same as A8. What is the difference?
Honestly, I'm not too sure what the question is about. I don't know what he means by Prometheus module for OpenStack and whether this is the same as we are using here. If he's referring to my presentation on the last one on monitoring, what I can say is that we are using the same one as the Helm chart for Prometheus operator, something that is community available. And what we have done is to customize it to adapt it to OSM needs. I hope that this somehow answers the question.
Yeah, and regarding the component itself, there is a Prometheus stack for OpenStack that I know that uses the same open source component. So from that point of view, it's the same system, the same Prometheus component. It's just that it's running. Of course, it's a separate instance dedicated to open source MANO Kubernetes environment.
Okay, they're coming in thick and fast now. What's OSM's point of view on integration with vendors' own VNFM?
I think that there were some questions that came earlier in the list, Gavin, just to be fair with.
All right.
Okay. I mean, because time is... So I see at the top that you mentioned commercially available distros and what are the available distros of OSM. I mean, there is a list at the beginning of the presentation. Well, actually, one of the presenters is providing one presentation. I mean, is providing a commercial distribution Whitestack. Also, one distribution is Canonical's Chan OSM. You have, but by the way, I think that here you can see the list of components, so I can show you how to fish about how to navigate around OSM community and who offers what. Okay, so in the distros you have also Tata ETSI as a distro, as I said, and Rift.io. Okay, so we have 4 commercial distros plus a lot of companies that are provide integrations, consulting, or an ad hoc integration if you need to. Okay, All this is available in this URL. So there you can check frequently what are the commercial offers. Okay.
Okay, and there was another one for, can we share a link to the Magma charm in the attachments?
Yeah, so the Magma charm was built for a POC and for this webinar, and it uses some tools inside the access gateways that are not yet upstream to the Magma community. But as part of the VNF onboarding task force, we are uploading all the details soon. I would say maybe in a couple of weeks, along with the images and everything ready for you to test it out.
Yeah, actually, let me complement that. Actually, we are preparing in OSM a way of building a catalog of the VNFs that are onboarded or test VNFs that we are using, etc., etc. So it's easier to locate. I mean, there's a lot of material in OSM website about our activities on this, but sometimes we are getting the feedback that it's not easy trivial to get it. So we are trying to restructure it so that information that Gianpietro has mentioned, along other that we are using in our Hackfest and other complex examples, will be easily available in a catalog of packages in the website.
There is now a question. I'm guessing OSM 7 supports light UI as before. There also a heavier UI, a version that supports more detailed views and/or features more functionality that we can download from download as part of OSM 7.
Sorry, I'm not seeing that question. Is lost somewhere in the list.
Yes, it's.
Okay, I mean there are few over that one marked as prioritized. Okay. Okay. So you said light UI. No, is the well, I'm not sure what is the heavier UI that is said in the question. I don't know if it's the former UI that OSM had that's discontinued, and actually it offers much less details that we have shown today. So if that is the case, that obviously it was much heavier. I mean is way more limited than the actual UI. So that obviously it's not planned to bring it back because it's very limited in comparison with all the new functionality that has been added in this one. Okay, essentially the change was motivated by the movement of OSM to cloud native, so it requires a lighter way of organizing the components, including the UI, and all the developments in OSM community since release 4, if I remember well, have been on that light UI. So that's seriously past whichever that we had in the former UI.
There is a question. We see a lot of vendor supporting Sol 001 Tosca descriptor. What's OSM's point of view on any future alignment in the community on a common descriptor format?
Well, in the case of modeling aligned to ETSI, what we are supporting is Sol 6, which is a YANG-based descriptor, which is functionally equivalent to the Tosca descriptor, and also standards and aligned with ETSI. So that's the path that OSM is following.
Okay. There's also, is there any specific OSM API calls implemented that they can use to protect a whole OSM deployment? By this they mean creating a backup or copy for recovery purposes.
I mean, there are no API calls to do that, but there are ways to do that are, again, usually available in the commercial distributions of OSM as one of the features needed for a fully carrier-grade operation. So in case you're interested in that, I suggest that you to contact one of the vendors or the integrators of OSM for those, let's say, commercial grade features.
One is to say, how do we see an ETSI MANO position compared to OSM? Can it say, finally, no ETSI MANO and all ETSI specs are standardized via OSM?
I'm not sure I'm understanding the question, sorry. Comparing them, well, actually, no. Well, no. The comparison. I think that this is a topic that we've covered several times, but the OSN obviously is providing an orchestrator, and we are aligned to what is happening in MANO. Obviously, we are adding other functionalities that are not specifically unrestricted to what an NVO does, and for instance, the slicing is an example of that. We are extending that framework for the convenience of the practical use, right, and the commercial use. And in that regard, obviously we are providing a superset of that because we have that demand, and actually our definition is not by one component or another, but about a platform that creates networks on demand in different infrastructures, and anything that fits into that category is in the scope of OSM. So sometimes we are going beyond what an NVO would do, because we want to cover use cases like the network slicing and others related to 5G that requires additional functionality that is covered by other standardized components, right? So that is also, I would say that is the comparison that we are trying to follow what is going in ETSI, and obviously what an NVO does, but not exclusively, because we need to cover wider functionality.
Okay, there is one question that's come in. Why is VCA deployed outside of the Kubernetes cluster? Is there any plan to include it in the Key 8 cluster in order to improve resiliency?
Again, what I described there was the setup for the basic installer in the community edition of OSM, which in this case happens to be the case that the VCA is outside Kubernetes. But in order to improve resiliency, again, the different commercial distributions of OSM support different means of doing that. As far as I know, all of them support VCA redundancy and resiliency in different ways. So again, what I was describing there is the community installation, which today has this let's call it a limitation, but this is not the case in the commercial distributions.
Yeah, again, let me comment, because this can be a source of confusion, and that the code base is exactly the same, right? It's simply that the variety of options that an installer, a commercial installer, might bring out of the box are bigger than the options that are mostly related to development processes and testing processes, etc., that brings the community installer in the same manner that happens with OpenStack, right? So there is a limited number of things that OSM as community provides as installer options that are growing in every release, but it's not the main focus. But everything that has been mentioned related to HA frame, HA combinations or ways of providing that, improving the resiliency of the components, etc., can be done if you install it component by component as a developer. Actually, if you are a developer of OSM, you will know how to do it, right? So in a fashion or whatever, but you need to know exactly what you're doing. In the case of commercial distros, is they try to make it as simple as possible for the user, because they are supposed to be operationally simple, right? And hence the advice. But from one to another, essentially they are sharing the same code base, and that is, so there's no trick that adds a new component in BCA, for instance, to make it HA, because this is not the case, right? It's the same component from the community that is packaged by the different distributions cleverly in a manner that is user friendly.
Okay. One further one's come in. Any ways OSM can automatically test the network service deployment after instantiation?
Well, actually, I think that it's been quite close, one of the demos, to show that. I mean, in the end, you can run a number of primitives even automatically to validate, and some of the actions that you can drive could be with the sole objective of testing the running a health check of the network service. So that is doable as long as you are planning to do that, and you want to integrate that functionality of self-checking. So it's possible. It's not anything out of the box, because it depends on the use case, obviously. But yeah, it's doable. And actually, that is one of the big values of if you want to use OSM in a CI/CD environment or something. That is one of the advantages, because you can guarantee that you deploy always the same manner of things, but also you can run the test, or you can run a series of actions in a manner that you can recreate as you wish. So that is essentially that is in the spirit of what OSM is providing.
And there's one more that's come in, but I'm not quite sure if it's right. It's whether how OSM handles the Helm, especially charm for VNFED that they have for K8.
Well, I think that maybe it's a confusion. Tomorrow will be this aspect will be very clear, actually, because they will have a deep dive on how OSM supports Kubernetes. But essentially, is that OSM you'll see tomorrow that can embed in the packages several Kubernetes-based components that could be based on Helm charts or UU bundles for that. And that would embed in those formats the information that you need to run those workloads as a part of a VNF or as a part of a network service. So there's no such a thing. You have minor changes in the VNFD to enumerate the components that your VNF has, including, say, that you have a VNF that has a number of VMs, a number of physical network components, and you have a number of charts, for instance, and you enumerate them in the descriptor. But one thing requires the other, right? So there's no one versus the other. Both of them are needed. Tomorrow you will see a couple of demos on that specific topic, so it will be much clearer.
Okay, well, we seem to have come to the end of the questions. I would just like to thank everyone again for attending and listening to this, and also to thank our speakers for giving a very complete picture of this first overview. And I would also encourage those who are very interested to attend the webinar tomorrow afternoon for the second part. Thank you very much.
Thank you, Gavin.
Thank you.
Thank you, everybody.
Bye.
Thank you.
Bye.
Thanks to the attendees. Bye-bye.